Alright, hello 7th grade. So today we're looking at misleading graphs and statistics. And usually when you hear the word misleading, you think, okay, well, something's lying to us or something's not right with these numbers. But numbers don't actually have to be wrong in order to be a bit misleading. And I can take actually the same numbers and put them on a graph and get two very different things. For example, if I have ages over here and your height over here, I can take these same numbers and we can, count by 1, 2, 3, 4, 5, 6, and we get a graph that looks like this. Whereas if we count by something like fives, we get a graph that looks like this. So if you were just looking at this graph, so which graph makes it look like you grew more? Well, this one. But I mean, they're the same numbers. There's nothing wrong with these numbers. It's just that we counted by something that made these numbers look pretty small in comparison. Now, there are times when you might actually want that, like if you were comparing your height to the height of, say, a tree or something that did grow to be like 30 feet. There might be a good reason to have a graph that goes up to 30, but in general, if you're just showing your height, yeah, you probably want this one. Because that gives a better picture of what's actually going on with your height rather than thinking, oh, well, I didn't grow very much at all. Or if you have something like this. So we have the number of points that person A, person B, and person C scored in a basketball game. You got 5, you got 10, and you got 20. Okay, well, just looking at these numbers, I mean, there's nothing particularly wrong with this graph. But if we're looking at the actual numbers, if we got 5 and we got 10, you would think that B should look twice as big as A. Does it? Does that circle look twice as big as that circle, or does it look a bit bigger? And if it looks a bit bigger to you, it's probably because we're comparing area. So if we're comparing 5 and 10, that's just the height. But if we take this circle, we can actually fit more than 2 of this circle in this circle, because we can have this circle and you can put this circle on top of it, and we've still got all this extra space left over. So this circle is actually more than 2 times as big as this circle, and we can do the same thing over here. So if I draw a circle this size, Miss P obviously can't draw circles, and I draw another circle the same size on top of it, well, that's more than twice as big as that. But if I'm looking at the numbers, 20 is only twice as big as 10. So that's another way to get a graph that's a little bit misleading. So what can we do to make this better? Well, actually, we're on the right track here with these circles. So instead of drawing a circle to match the height, we could take this first circle and then just draw however many of those circles would make up our number. So for 10, I would draw 2 of these circles, because these circles are 5 each. So I'd have a 5 circle and a 5 circle. And then if player C scored 20 points, we would draw 4 circles. Okay, that's a bit more accurate, because now we're just looking at the heights and we're just comparing things that are the same length. So this one looks twice as big as this one, which it should, because 10 is twice as big as 5. And now it's a bit easier to tell, okay, well, player C scored 4 times as many points as player A. So that's a bit better of a representation. It's a bit less misleading. It's a bit more honest. And you can actually do the same thing with some statistics, because we said that this was misleading graphs and statistics. So that was the graphs part. Here's the statistics part. And statistics, when we're talking about statistics right now, we're just basically talking about 3 of them. We're talking about your mean, your median, and your mode. There are a ton of other statistics that you could throw out there, because statistics is just a fancy word for numbers that are describing something about our situation. So your mean, your median, and your mode, those are 3 statistics that we can use. And your mean is what you usually think of when you hear the word average. So you add up all your numbers and you divide by your number of things. So that's your mean. So we're adding all your numbers and divide by your number of things. So usually when we say the word average, what we're actually talking about is our mean. Your median is your one that's in the exact middle once they're in order from biggest to smallest, or smallest to biggest. So it's in the middle when they're in order. And order either small to big or big to small. Doesn't matter, because your middle will be the same either way. And then your mode is your one that occurs the most. So it's the one that happens the most. And sometimes you'll have a mode, sometimes you won't. If all of your numbers are different, you don't have a mode. Okay, so let's say I'm looking at some numbers. Let's say I had 5 phone calls. And let's say the lengths of my phone calls were 2 minutes, 3 minutes, 4 minutes, 4 minutes, and then 57 minutes. So maybe I called my grandma or something and she wouldn't stop talking. So we had 5 different calls there, and we're going to find our mean, we're going to find our median, and we're going to find our mode. So if we want our mean, we're going to take 2 plus 3 plus 4 plus 4 plus 57. Divide by 5. Grab the calculator. So we get 2 plus 3 plus 4 plus 4 plus 57. Which gives you 70. Divide by 4 and you've got your mean is 14. So that's what we usually think of as average if you hear that word. So that's our mean. Our median, we said, is the one that's in the middle if they're in order from biggest to smallest or smallest to biggest, which conveniently they already are. So we got 2, 3, 4, 4, and 57. So 4 is the one that's right in the middle, which also happens to be our mode because that's the only one that's repeating. So if we were looking at those 3 numbers and we wanted to pick a number that would be a good representation of how long our phone calls are most of the time, which would be a good one to pick? Should we pick 14? Probably not the best thing to pick there because we've got 4 numbers that are on the shorter end, and then we've got one really big one. And what happens when you have one number that's really big or one number that's really small is that really throws off your average. So most of our phone calls are not around 14 minutes. In fact, we don't have any that are 14 minutes. We have 4 that are quite a bit smaller and one that's quite a bit bigger. So I actually don't have anything really close to our mean. Whereas either our median or our mode, in this case they're both 4, would probably be a good one to pick because we have 2 4s and that's pretty close to most of our numbers. So if we wanted a number that was a good representation of our data here, we would say most of our calls are around 4 minutes. So most calls around 4 minutes. And that one happens to be both your median and your mode. Sometimes it'll happen, sometimes it won't. Okay. So that's our mean, median, and mode, and this one's the best representation, whether you're calling that your median or your mode, because your mean's a little bit off. If you said most of your calls were 14 minutes, that wouldn't be very accurate. Now, there's nothing wrong with the numbers. That's our mean. You could say our average call was 14 minutes, but we actually didn't have any calls that were around that length. So the mean there would be a bit misleading. Alright, let's say I got some test scores. So let's say our test scores were these numbers, and we want to find our mean, our median, and our mode. I'm not going to rewrite all of these, I'm just going to put little plus signs between them. So if we want our mean, we're going to add them all up and divide by our number of things. So we got 95 plus 99 plus 92 plus 87 plus 88 plus 20 plus 89 plus 91 plus 90 plus 99, which gives you 850. And then you divide by your number of things, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that gives us a mean of 85. Okay, and then if we're looking for our median, I'm going to get rid of some of this stuff, because what we're going to want to do for our median is put these in order, because they aren't already. So we don't want to just go, oh, hey, that one's the one that's in the middle. Well, they're not in order. So, okay, our smallest one's 20. Then we've got a 87. We've got an 88. We've got an 89. We've got a 90. We've got a 91, we've got a 92, 95, and we got 2 of these 99s. Okay, so then we're looking for our middle number. So if we can start crossing these off, not this one, not that one, not this one, not that one, those ones on the end, not that one, not that one, not that one, not that one. Okay, so we're right between 90 and 91, and if your median isn't one number and it's actually right between these two, what we're going to do is we're going to find the average of those. So we're going to take 90 plus 91, divide by 2, which gives you 90.5 as our median. Okay. And then we're going to find our mode. Now, the only repeat we had was that 99 there at the end, so that's our mode. Again, sometimes you'll have one, sometimes you won't. If we didn't have any repeats, you just put no mode. Okay? Now, if we're looking at those three numbers, and we want to know which one's a good representation, which one's the best representation of what's actually going on with these scores, if you take a look at the mean, we probably don't want to use 85. Because we didn't do anything wrong with our math. It's just that we have that one number in there that's really low and is throwing off our mean. Because if we're looking at that 85, we have 9 scores that are bigger than that, and only one that's smaller. So aside from that 20, all of our numbers are bigger than that mean. So we probably don't actually want to use that one. Whereas if we're looking at our median, okay, 90.5, that's closer to most of our things. So that 90.5 is probably the most accurate representation of what's going on. We could say most of our numbers are pretty close to 90.5. I mean, if we're just looking at these, this one's only like 3 or 3.5 away. Our biggest one's only like 8 away. Most of them are pretty close if you ignore that 20 that's way down there. So most of our scores are pretty close to that. Now, which one of these numbers would you want to show your parents? Yeah, probably that 99. You say, oh, well, the mode of my test scores is 99, Mom, so I'm doing just great. I mean, that just happened to be the number that showed up twice as opposed to all the others showing up once. So this one's probably the most accurate. This one would probably look a little bit better if you want to show something to your parents. So there's your, and I mean, that could just as easily have happened with the lowest score as with the highest one. So this one's the most accurate. This one makes your grades look better. This one's not very accurate at all because there's just that one little low number down there that's pulling down your average. Okay, so if we want to be really accurate, this is probably the one we want. If we want to show off, this is probably the one you want. All right. So that's what's up with misleading graphs and statistics, and you don't actually have to have numbers that are wrong or numbers that are, not accurate, or numbers that we did something manipulated somehow in order to end up with something that's a bit misleading. You can just fiddle around with the right numbers, and if you use your mean instead of your median, or if you use your mode instead of your median, you can make these numbers look not as not either make them look not as good or make them look a lot better than they actually are. So you can actually skew this either way. So if you're looking at like a graph or something and they say, well, the average is this, or most of the numbers are this, take a close look at whether they're actually using your mean, your median, or your mode there, because depending on which one you're using, you could get 3 completely different results. All right, so that's just something to be aware of, and go ahead and check out the numbers in the description below, and I'll see you in the next video.